Okay, today we're looking at prime factorization, least common multiple, and greatest common factor. So we're going to look at two numbers, 840 and 240. We're going to start first by finding the prime factorization. So we're going to divide 10 by 840, and that's 10 and 84. And then to divide 10 would be 2 and 5. And 2 and 5 can't be divided any further. Those are prime numbers, so we're going to circle those just to help us out. Then we're going to split 84. So 2 times 42. 2 is a prime number. And then it would be 2 times 21. 2 is the prime. And then 21 can be divided. 3 and 7. And those are both prime numbers, so we circle them. So the prime factorization of 840 would be 2. And then there's 3 2's. So it would be 2 cubed times 3. And there's 1 3. Times 5. And times 7. And when you multiply all those numbers together, you get 840. So the prime factorization of 840 is 2 cubed times 3 times 5 times 7. Now we're going to find the prime factorization of 240. Same thing, we're going to do 10 and 24 on this one. 2 times 5 is 10. We're going to circle those because they're prime numbers. And then 24 can be 2 and 12. Circle the 2. We're going to split that 12 by doing 2 times 6. Circle the 2. And then 2 times 3 equals 6. And both of those are prime numbers, so we can stop. So the prime factorization of 240 would be 2, and there's 4 of them. So 2 to the 4 times 3, there's 1, and then times 5, and there's only one of those. And if you multiply all that together, you get 240. So the prime factorization of 240 is 2 to the 4th times 3 times 5. So to find the least common multiple, we're going to take the greatest, what's greatest in both of the prime factorizations. So we're going to look at 2. We have 2 cubed on this side, but 2 to the 4th on this side. So we're going to bring down 2 to the 4th, because that's the greatest number in both of the prime factorizations. So times, both of them have a 3, and then times, both of them have a 5. And then even though this one doesn't have a 7, we're still going to bring down the 7, because that's the greatest amount of both of those. And if you multiply all those together, you're going to find the least common multiple. And the number for that is 1,680. So the least common multiple for 840 and 240 is 1,680. Now we're going to find the GCF, or greatest common factor. To find that, we're going to take what is at least in both of the two prime factorizations. So there's at least 2/3 in both of these numbers. So we're going to bring down the 2/3, then times 3, because there's at least 1 3 in both, and then times 5, because there's at least 1 5. But there is not at least 1 7 in both of the prime factorizations, so we do not bring down the 7. We multiply all that together, and we get 120. So the greatest common factor for 840 and 240 is 120. So now we're going to prove our answers. We're going to check our work. So we're going to do the slide method. We have 840, comma, 240. So what we're going to do is we're going to see what number divides into both of them evenly. So we can pull out 10, and we're going to write that on the side. So 10. So 10 times 84 is 840. Then 10 times 24 is 240. Let me draw a box. Okay, now we're going to look at what can be both divided into both of them. So that would be 4. 8 into 24 is 4 into 84 is 21. And then 4 into 24 is 6. Okay, let's see what can be divided in both of these. And that would be 3. 3 can go into 21 7 times. And 3 can go into 6 2 times. And then we stop there because those can't be factored out anymore. So to find the LCM, we multiply everything on the side. So 10 times 4 times 3 times 7 times 2. And that equals 1,680. And then to find the GCF, we're going to multiply everything on the side. So 10 times 4 times 3. 10 times 4 times 3. And that equals 120. So the LCM is 1,680. And the GCF is 120.